Okay, so we want to do number 20 in 1.2. So we've got f of x is 16 minus x squared. And then they want me to compute and interpret a bunch of stuff. So for part A, they want me to compute f of 2 minus f of 0 over 2 minus 0. Okay. Half of that's easy. Which half of that is dead easy?
2 minus 0.
2 minus 0 is pretty easy. Okay, so I think on the bottom we're going to get 2. On the top, what do I need to do?
Plug in and calculate f of 2
I need to calculate what f of 2 is.
and subtract f of 2.
Okay, so I'm going to just put spaces here, right? F of 2 is going to be 16 minus 2 squared, which is 4. And this guy's going to be
16 minus 0 squared.
16 minus 0 squared is going to give me 16. Okay, so the 16s will cancel. And I'll get out of that what?
Negative 2.
Negative 4 over 2 gives me negative 2. Awesome. Okay, what does that mean?
That means that you got negative 2.
Yes, that means the answer to compute is negative 2.
The rate.
Ah,
Yeah.
close. Yeah, this is the slope of what? So what's the picture I should be thinking of here? You guys remember a picture that goes with 16 minus x squared?
It's
a
a
Second.
parabola flipped upside down and up 16 units.
Yeah.
Perfect. This is an upside down parabola shifted up 16 units, right? So that's going to be my kind of overriding picture here. So I've got this vertex and parabola. This is at 16 high. Where are those? On the x-axis, which means the output is 0. So that 0 is 16 minus x squared. So what's x?
4, negative
4. Negative 4. Cool. Okay, so that's what I know about this picture, right? This is my overriding picture that's happening in all the parts. So in part A here, right, part A is going to be red interpretation. Where are my two x values I'm talking about? What's the slope of that line, in other words? Can you guys read off the 2 points I used to make that line?
2
F2
0.
minus F0.
Good. So one of the points is f of 2 in the y and 2 in the x, right? That's the point that's above this guy, right? That's 2 comma f of 2. And the other one is what? 0 comma f of 0. So that's here. And so the line I'm talking about is this little secant line here. You guys see that? So this negative 2 is the average rate of change on the function f from, so average r of c, right? Rate of change between,
Vertex and that point.
good, the vertex and 2, right? So between x equals 0 and x equals 2 of average rate of change between of f of x. Cool? You guys see that? So on average, this function goes down 2 units for every 1 unit of run in this little chunk. You guys see that? Is it ever actually equal to negative 2 in there? Like, is this, I don't know, is it ever actually going down at that rate? It's maybe a weird question, right? I don't even really know what it would mean for this thing to be going anywhere at any rate, because it's not a line. You guys see that?
Well, at the point where that line is tangent to it, you could argue that.
Oh, perfect. Good. Yeah, there's one point in here. There's a deep theorem in calculus that tells you there's one point in here where the instantaneous rate of change is actually equal to this slope. That thing's called a mean value term. Super cool. Cool? Questions, things? All right, how about we do B? So calculate b, right?
Or study zero.
See, so we got over 2, right? We already calculated f of 2, yeah? Oh, well, we almost calculated f of 2. It was 12.
So zero minus four.
And f of 4 is 0. We already calculated that too.
Definition.
Okay, I calculated f of 0, or f of 4 right here. You're going to see this point here should be 0, comma, f of, or sorry, not 0, 4, comma, f of 4. Right, and that's on the x-axis, so that f of 4 is 0. I actually did that up here. Right, I went and looked for what input gives the output 0, and then I found that the input was either 4 or negative 4 to give the output 0. Okay, so I know what output 4 gives. It gives the output 0. You guys cool with that? And then the 12, where'd I get the 12?
That's just 16 minus 4.
That's 16 minus 4, which I had right here. You guys cool? Okay, so I got 0 minus 12 over 2 gives me a grand total of what? Negative 6. And how do I draw that on my picture? What are the 2 points that I'm interested in for
X equals 4 and 2.
good? From x is 4 and x is 2. So this is the secant line you're looking at. Is it clear that should be steeper than the secant line I had before? Totally. See
How
that?
many times steeper?
3 times steeper. Good. Perfect. You guys cool with that? Right? It goes the same distance in the x and drops 3 times as far in the y. So if we were going to interpret, we would write this exact same sentence. This is the average rate of change between x's 2 and 4 of the function f of x. Should we do C? C should be really easy. The run's 4, right? What's the rise?
16. Oh, negative 16.
Negative 16? You guys see why?
0 minus 16.
Right? That's the rate of change between here, the vertex, and down here, right? So that drops 16 units and runs 4. So that's the slope of this black line. Cool. So I got negative 4 out of this, and this would be what? What would my sentence interpretation for this one be?
Average rate of change.
Perfect. This is the average rate of change between 0 and 4. The other one would be run backwards, right? Which would still give you this. But. Other question? Or this? You could just calculate, right? F of 4 is 0. 16 minus 16. That's from just plugging 4 in up here. And calculate f of 0. That's minus 16, or that's 16. I'm subtracting it. So that's one thought. The other thought is you could just look at the picture. So I know this is between 0 and 4 for x inputs. So the run is 4 and the rise is negative 16 units. Cool? Either way. Did I get your question someplace in there?